Okay, let's take a look now at what one does with graphs. What I mean by that is once you've built one, one has to make interpretations. What does it tell you? And we can break down what one does with graphs into three main categories. One looks for possible correlations, and from that one could perhaps establish causation or causality, and finally one perhaps seeks to seek a mechanism for how this is happening. Let's take a look at this. We see here a graph, and the graph says that on the x-axis it shows you the degree of education that a person achieves from no high school diploma all the way up to a graduate degree. And it shows test scores in the areas of critical reading in blue, and math is in red, and the writing is in green. Now, this graph establishes what we would call a correlation. And the word correlation simply means that there's a relationship between things that happen or change together. If you look at the graph, as one item changes, the amount of education or a higher degree achieved, then the other one changes with it. The test score goes up in these different areas. Therefore, there's a correlation, we would say, between the degree of education or the amount of education and the test score, and that's called a correlation. Now, what are types of correlations that you can have? Well, we can see in the first one, you can have positive correlations. In this one, this is the hours spent revising a paper on the x-axis, and the results on the exam go up. So as hours go up, the results in the exam go up. And one can then generate a conclusion, or what we would call a causation, and says that revising increases success. You can draw that conclusion from this graph. But you can also have a negative correlation, which doesn't mean anything's bad. It just simply means that the direction of the graph is in a negative direction. So here we see that the flu jabs given, which is the same as saying the number of flu shots given, as it gets greater, then the number of people with flu go down. Therefore, that's good. But it's called a negative correlation because when the x value gets greater, the y value gets smaller. And so the correlation we would say is when jabs are given, the number of people with flu falls. That's the correlation. And again, you can move one step further and generate a conclusion. And the conclusion is that flu shots prevent the flu. Let's take a look at another example. This is another negative correlation, and what it shows that the GPA a person has, if it is higher and higher, negatively correlates with the hours spent on TV, meaning that the higher GPA tend to have fewer hours of TV watching. Finally, another positive correlation. This positive correlation shows that the arm span of a person gets greater, correlates with a greater height of that person. Now, does everything correlate? No, it doesn't. In this given case, the average time spent watching on a TV does not have any correlation or any connection with the size of the television that the people are watching. You would conclude that there's no correlation or no connection between these two variables. Now let's take a look at another idea. Here you have minutes spent reading and the page is read, and it shows two different items being read, Dostoevsky and Batman comics. Now, can we establish a causation here? A causation accounts for why things that happen or change together. It is, if you will, a because or a therefore. So the statement is this. Correlation statement, if the minutes spent reading increases, then the number of pages read increases. However, the number of pages read per minute is greater for Batman comics than for Dostoevsky. Notice the correlation statement is really just a summary or a verbal description of what the graph says. Now, a causation or explanation of the statement would be, therefore, the more time a person is given to read, they can cover more words. There are more words per page on Dostoevsky, therefore fewer Dostoevsky pages are read than Batman comics. Notice the causation statement delves into why or what that relationship is all about between those two variables. Now, here's another statement. Correlation statement would be, if the percentage of employees that complete specialized training increases, then the cost per unit produced goes down. So there you have a correlation statement, if then. What about a causation statement? You could then say, therefore, if you increase the amount of specialized training, then you will have a decrease in the cost of production. So we can then move away from just a description of the graph and start to move into what's causing what. Now we have to be careful here. Correlation is not causation or causality. Now, what does that mean? This is a bit blurry, but it's an interesting idea. This is, by the way, factual data. It is true that if you increase the ice cream production in a certain area, it is also true that there is greater drowning deaths. You can now then make a cause statement, which would be, therefore, ice cream causes drownings. Well, that's a very silly statement, and of course that's not what happened. It is true, ice cream production and drowning deaths do correlate, but it's meaningless. The cause of this connection is the fact so the cause actually is this. During the summer, people consume more ice cream because it's hot. That's the cause of more ice cream. During the summer, there's more drownings. Well, that's because more people are swimming. Therefore, there's more drowning. So summer causes ice cream, summer causes drowning. But ice cream doesn't cause drowning. They're correlated, but the one does not cause the other. And that is sometimes a common mistake. Here's another one. Here is the average number of ice creams sold on the x-axis and the percentage of population reporting skin problems. So we could create a correlation and say, if the average number of ice cream increases, then you have a greater reporting of skin problems. You might leap to the conclusion that the cause of the skin problems is the ice cream. No, it's not. It's because during the summer people eat ice cream, and during the summer people are outside more, and it's the summer that's the problem with the skin and the ice cream, not the other two together. Now let's talk about nonlinear relationships and describing a graph. See, in this case, there's not a linear relationship. What we mean by that is, as the age of a person gets larger and larger, then the target heart rate gets lower and lower. Well, that's true, but there's a better description here. You would say the person's age from 12 to approximately 20 leads to a slight decrease in the heart target rate. However, after the age of 20, the heart target rate falls more rapidly to the age of 70. Notice we address the issue that how quickly the heart rate target is changing is not consistent for the entire age of the person. Let's take a look at these three. In a chemical reaction, looking at graph A, in a chemical reaction, when the temperature starts to rise, the reaction rate starts to rise. However, at first, an increase in temperature causes a slight increase in the reaction rate, but as the temperature continues to go up, the reaction rate gets greater and greater even faster. Let's take a look at B, an explosive reaction. You would say, at first, as the temperature starts to rise, the reaction rate also rises. However, at a specific point, a slight increase in the temperature causes the reaction rate to dramatically increase. Notice how the description captures that the rate of the reaction is not consistent throughout a temperature change. And finally C, let's see this description. You would say that as the temperature increases in an enzyme catalyzed reaction, the rate of the reaction also increases, but only to a point. At a specific temperature being reached, the reaction rate suddenly falls off very dramatically. So the graph is referred to as a nonlinear graph, as the change is not consistent throughout the whole way. Now, knowing that there's a connection between two things is not the same as knowing what the mechanism or what the explanation for the change is. Let's take a look at that. Here, this graph says that the number of doctors per million in 1975, as the number of doctors increased in a certain area, then the life expectancy of a female goes up. You will notice that at first, as you increase the number of doctors per million, the survival rate of females dramatically increases. However, at approximately 2,000 doctors per million, then the life expectancy of the female does not increase as you add more doctors. It levels off, and that is the phrase we would use. So this is a nonlinear system, and we identify what happens. Now, why does this work? What is the mechanism? Well, the mechanism for this is if you increase the number of doctors, you get better medical care for women, and the result is more women have a better life expectancy. However, there's a saturation point. At some point, the addition of more doctors does not fulfill medical needs for women, and therefore you don't see a impact by adding more doctors. The phrase for it gets saturated. So that last item would be the explanation or the mechanism as to why this data occurs. Now, let's take a look at one final setup here. What you would say here is that if since 1880, if the amount of time, let's try this again. What this graph is showing is as follows. From 1880 to 2000, if the CO2 concentration increases, you can see that on the right, from 260 to 400 parts per million, then the global temperature has increased by 1.5 degrees. So the correlation statement here is if CO2 concentration rises, then the global temperature rises. And you can see that in the opening statement here. You could go on to say that there is a positive correlation between the increase in CO2 levels since the 1880s and an increase in the overall global temperature. That's a correlation statement. It's a verbal statement what the graph is saying. What's the causation? The causation says that therefore the increase in global temperature is caused by the increase in the CO2 in the Earth's atmosphere. So that's referred to as the causal relationship, that one is causing the other. What is the explanation or the mechanism? And the answer is this. This provides the mechanism that will produce these results. It's a positive feedback loop where increasing the CO2 increases global warming. The global warming causes increase in evaporation. The increased water vapor, which is a heat trapping gas, causes a warming of the atmosphere, which causes more global warming, increases evaporation, etc., etc. So this slide shows you really the three key ideas of what do you do with a graph. One, it allows you to make an if-then statement. It indicates what kind of correlation it is. The second, it allows you to perhaps state causation, which is therefore one variable is causing the other. And finally, it forces you to then explore or come up with an explanation or mechanism that would produce this connection.